problem 5, 1.5 from Everrace. All right, let's do this. So a car has a maximum acceleration of a naught and a minimum acceleration of negative a naught. The shortest possible time for the car to begin at rest, then arrive at rest at a point d, distance d away is what? Okay, so if you look on YouTube, they'll either do like two things. They'll either do like Lagrange multipliers. I can't spell Lagrange. And or two, they'll do the triangle method. And that's from like Carrara, if you know him. Yeah, he's like he also did like a lot of FLSMA stuff. So here I'll show you the triangle method. So basically what triangle method states is like so basically it's like we know that it cannot be in between a naught or negative a naught. It has to be one of them, so it becomes a triangle. Sorry. Because think about it, right? Let's say I have another one, right? I accelerate a little, I start coasting. I accelerate a little, I start coasting. I accelerate a little, I start coasting. And this is just wasting so much area. Because look, let's just section out the squares. We get this plus this part, this plus. Okay, hold on. We have this little triangle plus this big section here plus this big section here. And all just becomes a triangle in the end. And that is their strategy, really. So they say this is a naught, this is negative a naught, um, d over 2. Find the distance under it. It's v of t, by the way. So you just find the distance. So d over 2 equals 1 half a 0 t squared. And that's only for this half. So you get d equals to a naught t squared, d over a naught square root equals to t. And that only goes for this section, so you have to multiply by 2, because we didn't consider this section. Bang. Okay, so that is the solution to the problem, but I do want to propose a different solution. I guess some people would have solved it this way. This is how I solved it the first time. But this solution, triangle method, is definitely a lot easier if you use your brain. But if you really just want to be brainless, like you can just do this method without shape. And this one's just like actually just using kinematic equations. So we're gonna start with the VF squared equals to 2AX, right? Because think about it, the initially there's at rest, so bam, right? So this is stage one. This is going up the hill, right? This is think about like this triangle. Then for stage two, you have 0, right? Because at the end it's 0. It's 0. 0 equals to VF squared. Think about it, because you start here, this is VF. You end at VF in this phase with a 0 here. Now you start at VF in this phase going down, and it's 0 here. Minus 2AX. And you get the same equation twice. 2AX. So now we just solve, right? Because so this is going to be displacement 1, displacement 2. So VF squared all over 2A. Oh shoot. It's 2A equals to X. And you just multiply by 2, right? 2, right? And then because there's going to be 2, right? So think about it. You solve this equation, and if you rearrange this equation, are actually the same. So what I'm doing here is I'm going to solve for x1, and that'd be the equivalent of solving for x2 because the equations are the same. And I'll multiply by 2. Squared all over a equals x. So that's like the key relation we gotta know. And then yeah, sorry, I did eat food real quick. But yeah, I'm back on the track, so let's keep going. VF squared equals to, we're gonna say this is combined, right? Because remember we added these two. So it's gonna be AD and VF equals to square root AD or A naught D. And now we have to, now that we have velocity, we can look for time, right? So the time t equals to VO all over A. That makes sense, right? You guys get that. And remember, that's only for going up, and it would be multiplied by 2 because you have to go down as well. See, there's symmetry in everything. You know what I'm saying? That's Noether theorem. Something about the Noether theorem. Anyway, this is going to be the total time. And I think you know where we're going with this. I'm going to put that in there. T equals to 2 square root A O D all over A, and you get T equals to 2 square root D over A 0. So that's how you do it with kinematics, pure kinematics. There's no graph. This is definitely more intuitive. You should probably train this actually more because feels FeelsMA really looks for this. Like, can you use like the most efficient solution? Can you like really like see the solution or something like that? It's a lot about like using like symmetries and using tricks to figure out the problem quicker. Oh wait, was that from last video? Oh, it was. So cool. I never erased a board. Oh yeah, I hope you guys enjoyed this video. I made it pretty early in the morning, so that's why I had to stop. Yeah, sorry about that. But yeah, I'll see y'all